Right now, dozens of massive Neo-Panamax container ships are sitting completely idle in the Pacific Ocean, forming a multi-billion-dollar floating traffic jam. They are stuck waiting to enter the Panama Canal because water levels have dropped to historic lows. The Panama Canal is failing. A channel built to connect two of the largest bodies of salt water on Earth relies entirely on fresh rainwater to function. A $270 billion global trade route is being choked off by a simple lack of rain. This reveals a central mystery of the isthmus. Why does a megaproject connecting two oceans depend so heavily on the clouds? Most people imagine the canal as a simple, flat ditch dug straight through the land, allowing the Atlantic and Pacific to naturally meet at a single shared sea level. This diagram shows the actual tidal realities on either side of the isthmus. While the Atlantic side experiences mild tides of about 60 centimeters, the Pacific Ocean sits roughly 20 centimeters higher and fluctuates by 6 full meters. If engineers had successfully dug a simple, flat ditch between the two coasts, it wouldn't have gracefully equalized. Instead, those extreme Pacific tides would have created a violent, unnavigable strait with currents rushing violently back and forth. To solve this tidal nightmare, engineers abandoned the sea level cut. They built a massive, high-elevation artificial bridge made of water, a gravity engine that lifts ships up and over the landmass. Recognizing this geographical trap reveals the project's true scale, an advanced war of hydrodynamics, logistics, and disease. The first attempt to build the canal was led by Ferdinand de Lesseps and the French in the 1880s. De Lesseps insisted on a sea-level trench, ignoring the tidal disparities and the local epidemiology. Over 22,000 workers died during the French era, largely succumbing to yellow fever and malaria contracted in the dense jungle. In an attempt to protect patients from ants, French medical staff placed hospital bedposts into shallow bowls of water. These stagnant pools unknowingly created the perfect indoor breeding grounds for the Aedes aegypti mosquito, turning the recovery wards into highly efficient vector factories. When the American effort began, Chief Sanitary Officer Dr. William Gorgas implemented a radical shift in strategy. He targeted the mosquito directly, executing an aggressive, island-wide fumigation and screening campaign. The French effort collapsed under the weight of a microscopic biological enemy they were accidentally cultivating in their own medical wards. With the biological threat neutralized, John Frank Stevens arrived at the Culebra Cut with a critical insight. The mountain was a massive railroad routing problem. Stevens designed a network of 350 miles of shifting parallel tracks. This continuous loop of dirt trains maintained a hyper-efficient rhythm. At the dumping grounds, steam windlasses rapidly swept debris off flat cars, immediately sending them back for the next load. The sheer industrial scale of this earth-moving operation served as potent political propaganda, showcased by photographs of President Theodore Roosevelt inspecting the equipment firsthand. The logic of early 20th century system management effectively dismantled the mountain, transporting and exporting the debris in a continuous industrial flow. Engineers dammed the volatile Chagres River, intentionally flooding the surrounding jungle basin to create Katoon Lake. This sprawling, high-elevation lake serves as the battery for the entire canal mechanism, storing the immense hydrostatic pressure required to operate the system. This diagram shows the mechanics of the miter locks. The doors are angled upstream, so water pressure naturally forces the joint tightly together. 26 million gallons of water then flow upward into the chamber through subterranean culverts, powered entirely by gravity, utilizing zero mechanical pumps. This exact same pumpless mechanical elegance continues to effortlessly lift colossal modern cargo vessels over the landmass today. By capturing the heavy rains of the surrounding jungle, engineers turn the region's climate into a self-powering gravity engine. The mechanical triumph of the canal often obscures the darker geopolitical reality of the zone during the 20th century. San Jose Island, located off the Pacific coast, served as a dense jungle testing ground for the United States military to evaluate chemical weapons during the World War II and Vietnam War eras. The military abandoned thousands of lethal munitions in the area, leaving unexploded 1,000-pound bombs containing mustard gas and phosgene sinking slowly into the jungle floor. This toxic legacy sits at odds with the traditional narrative of a purely humanitarian and scientific achievement. Today, the canal faces a much more visible threat. The once reliable rainfall powering Gatun Lake is dropping to critical levels under the strain of shifting global climates and intense El Niño patterns. The drought has forced the Canal Authority to drastically reduce daily ship transits. The resulting bottleneck is so severe that shipping companies are paying auction fees of up to $4 million just to skip the line. This vulnerability has accelerated a $7.5 billion response from Mexico. The interoceanic corridor is a land bridge and railway designed specifically to bypass the waterway entirely and move global freight by train. It is a striking historical irony that humanity's largest water project may be rendered obsolete by a modern evolution of the exact same rail logistics John Frank Stevens used to build it. We build massive systems to temporarily conquer geography, but eventually the climate reclaims the machine.